Let's set up our development environment first. We're going to have a Node web server, and we want to write React components for the front end, and we want our Node web server to render initial static HTML from our front end React components. We also want a Node API server to talk to the database. To keep things simple, I'll create one Node project to perform all three tasks. We don't want to optimize things very early on. I'll be tracking the progress of the project we're going to build in this course using GitHub. This is the repository that I'll be using under JS Complete Learn Full Stack JavaScript. Every video in this course will have a Git tag associated with it. You should clone this repo and try things out with me, and at the end of each video, you can compare your code with the code at the Git tag for that video. This repo will also have a script to load some test data for us to start working with, and also all the CSS that I'll be using in this course so that you get the same look and feel of what we see here in the course. If you're comfortable setting up a full stack JavaScript development environment, you can actually skip this video and check out Git tag v1.2 to fast forward to the point we're going to start with in the next chapter. However, I recommend going through this setup video as I'll be explaining key things about the structure of the project. I've already cloned the course repo into my machine under this full.js directory. To start any Node project, your first step is to create a package.json file to store general information about the project and track its dependencies. You can generate a package.json file with this npm init command and either keep the default answers or type new answers. We have a package.json file, which means we can start documenting and installing our dependencies. I'll install them one by one here so that we talk about them as they install. We're going to have two types of packages. The main dependencies are the packages our code will use in production, and we'll have dev dependencies that are only used in a local development environment. Let's start with the main dependencies. To create a Node web server, we're going to use Express.js, so that would be our first dependency here. npm install --save express. The --save will write this dependency to package.json. Our database of choice for this course is MongoDB. To connect to Mongo from Node, we need a driver, and we'll be using the official driver here, which we can install as npm install MongoDB. Note how I used shortcuts for install and --save because, well, I'm a lazy typer. Express and Mongo cover the main backend dependencies that we need. Our front end is going to be purely React and nothing else. So let's bring in React here with npm install React and React DOM. We use the React library to describe our user interfaces and the React DOM library to render those user interfaces on both the front end and the back end. We're going to introduce more dependencies later, but for now, this is a good start. Let's now install our dev dependencies, the first of which would be Webpack. Since we're going to be writing modular code everywhere, we need a tool to translate modular code into something that browsers understand today. Webpack is the most popular tool for that job. As a Webpack loader, we're going to use Babel to transform the JSX extension code into what React understands. We'll also use Babel to transform a few of the modern JS features that are not yet supported natively in all browsers. Here are the packages we need to make all that happen. Babel CLI, Babel Loader, Babel Preset ES 2015, Babel Preset Stage 2, and Babel Preset React. I'll explain how to use these presets in a little bit. When we change things in a Node.js project, a restart is required for the changes to be reflected in a running process. But instead of manually restarting Node, let's bring in the nodemon package, which can monitor our files and auto-restart Node for us when we save changes to disk. Finally, I'm a big fan of ESLint, and I do not work in any project unless I have the eyes of ESLint to watch over my shoulders. I can't say enough about how important this is, but I hope you trust me on this one and npm install ESLint, ESLint plugin React, and Babel ESLint. I won't go through configuring ESLint itself because it's beyond the scope of this course, but I'll add a ready-to-use with this project ESLint configuration file to the GitHub repo, and you can get it from there. You can see the exact versions I'm using in this course here in package.json. You'll probably see different versions when you install them yourself, but As long as you use a version that's on the same major version level here, which is the first number, you should be okay matching the experience I'll be going through here in this course. You can always install specific NPM package versions using an @ after the name. For example, to install this same Express version I'm using, you can do npm install express at 4.14.0. And of course, if you just copy my package.json file, you can install the exact same versions with an npm install command. I'm going to create an initial directory structure for this project now. First, let's have all of our JavaScript frontend modular code under a source directory. It's a popular convention to name this directory source because it will be the source of our generated working files. Another popular convention is to have a public directory to host our static assets like HTML, JavaScript, and CSS files that will actually be loading on clients. We're going to have Express serve these public files directly with its static middleware. Finally, let's create a directory for our backend API server. I'll add empty files to these directories so that I can commit them to the GitHub repo. An index.js file in the API directory, an index.html file in public, and an index.js file in source. The index name is usually used to reference the starting point in every directory. Let's now prepare some NPM scripts. We will not be doing any automated testing in this course, although that's probably a very bad decision. But I trust that you know the value of writing tests for your code. Testing is a big subject by itself, and I'll probably have a course dedicated to testing Node and React applications, maybe after this one. The first script we need is to run the Node server, which I'll put in a server.js file. So our start script would be to node server.js. But since we want our code to work with Babel and NodeMon, we want to add a NodeMon execution wrapper and use Babel node instead of Node. I'll also ignore the public directory from NodeMon watch, as changes there are usually driven by changes in the source directory. To transform the source files into a bundled file for the browser, let's have a dev script that fires the webpack command, using the -wd flags to also run in watch mode and development mode. We'll need to configure Webpack to work with our structure, which is a long story, but I'll copy the configurations here and talk about them. In this webpack.config.js file on the root level, we tell Webpack to start from the index file under the source directory and bundle all the modules we depend on inside that file into a bundle.js file under our public directory. Then for every file that ends with a .js, we want to run the Babel loader on it. The Babel loader will take care of transforming the non-standard JS that we'll be using, like JSX and ES 2015 modules, which are not yet supported natively in browsers. To configure Babel to work with our selected presets, we can add a .babelrc file on the root level and add the following code. This instructs Babel to use these 3 presets. React is used to transform JSX, and the other 2 presets for us to safely use JavaScript modern features and not worry about browsers that do not understand them. I picked stage 2 here because I think any proposal that makes it to the draft stage has a very high chance of getting finalized as is or with very small modifications. Finally, here's the promised ESLint configuration file, which you can find on the root level in the Git repo. With all these configurations out of the way, let me commit all the changes here and tag this point of the course as v1.2 to match the video number.